Alright guys, so if you will turn in your assignment, so this was yesterday's homework, hopefully you already did that. Turn for me please to the second day. So we're starting here. Okay, so these are Thursday's examples that we're going to work together. So remember what we talked about yesterday. We said that exponentials and logs with the same base are inverses. And remember, the reason that's important is they cancel out. So for example, if I'm working, let's say let's start with number 2. I have 10 to the power of, and then I have log 12 minus log 2. Well, remember that whenever my logs are subtracted, I can just do 12 divided by 2. That gives me a log of 6. And then remember that whenever your log doesn't have a base, that means it's really a base 10. So then I have a 10 and a log base 10. Those cross out. I just get 6 as my answer. Okay, take a look at number 1 right next to it. I have log little 7 of 5 plus log little 7 of 2. Okay, well when it's a plus in the middle, I'm going to do 5 times 2. That gives me 10. So I have 7 to the log 7 of 10. But then remember what happens. 7 and log 7 cross out. Just my 10 comes down. Okay, next one, let's look at number 4. Okay, first thing I need to do is move these little 3's and these little 2's up. So now I have 5 to the power of log 5 2 to the 3 plus log 5 3 to the 2. Okay, well think about 2 to the 3, that's really 8. 3 to the 2, that's really 9. And so if I have a plus in the middle, then I need to multiply 8 times 9. That gives me 5 log little 5 of 72. And then from there, remember what happens. 5 and log 5 cross out. My answer is just 72. Now, number 5 is a little bit trickier. Notice that my base here is a 3, my base here is a 9. That's not going to work. But I know that 9 can be rewritten as a 3 squared. So I have 3 squared log little 3 of 5. And now that that's a 3 and that's a 3, I can bump this 2 up. So I'll have 3 log 3 of 5 squared. Okay, well think about 5 squared, that's really 25. So that's 3 log 3 of 25, and then my 3 and my log 3 can cross out. 25 is the only thing left over. Okay, take a look at number 6. I see this is a log 2. That means that my 8 needs to be converted to be a log 2 as well. Well, remember, in your chart, we know that 8 is 2 to the 3. So I'm going to rewrite this. It's going to be 2 to the 3, log little 2 of 3. And now that I've converted my 8 into a 2 to the 3, I can jump that 3 up. So I have 2 to the log 2, 3 to the 3. Now, if you're confused on how I'm converting these, remember, 3 to the 3 is just 3 times 3 times 3. So 3 times 3 is 9, times 1 more 3 is 27. So I have 2 log 2 of 27. Those cross out. 27 is your leftover answer. Okay? Hopefully that makes sense to you. Let's come down here to our next little section. So we have some exponentials. Let's go right side. How do I cross? Actually, yeah. Let's do number 8 instead. Okay, so I have a 2, 5x plus 2, and then a 2, 3x minus 4. Remember that we learned yesterday the way that you cross out a 2 is you apply a log base 2 to both sides. So if I apply a log base 2 to a base 2, those guys are going to cross out. And my 5x plus 2 is going to transfer down. So now I have 5x plus 2 equals, other side, log 2 and 2 cross out, 3x minus 4. Then from there, bring the baby to the mama, so minus your little 3x across. 3x minus 3x is going to cross out. 5x minus 3x is going to give me a 2x left over plus 2 equals negative 4. Okay, now think about from there. For me to cross out this plus 2, I need to minus 2. So 2 and negative 2 cross out. Well, then I have 2x equals negative 6. Because if it's negative 4 minus 2 more, that gives me negative 6. Then from there, divide by 2 on both sides. X equals negative 3. Okay. Next one, come down to number 11, right below it. So I noticed that I have a 4 here. I want to log 4 on both sides, but I can't do that with this half in the front. So I'm going to multiply by 2 here, multiply by 2 here. Now, 2 and half cross out. So then at that point, I have 4, 3 minus x equals, and then 10 times 2, now that's a 20. Now, from here, I could look at my low common base chart, but what I'm going to notice is that 20 is never a base 4. So the only way for me to fix that is to do a log base 4 on both sides. So remember, at this point, 4 and 20, they don't have a common base with each other. So that's why I'm choosing this method here to solve. So log 4 and 4 cross out, 3 minus x is going to transfer down, and then that you're going to type into the calculator. So let me grab one of those, show you how to do it in case you have forgotten. Okay, so you're going to do alpha window, okay, alpha here, window here, go down to number 5, which says log base, and then I'm going to let 4 be my little number, 20 be my big number. So I did log 4 of 20 equals, and then I got 2.16. Then from there, I got a 3 over here. I need to minus that across. 2.16 minus 3 gives me negative x equal to negative 0.84. And then remember, negative x is really the same as a negative 1x. So I'm going to divide by negative 1 on both sides. X is going to be positive 0.84. Okay? Alright, last one we're going to do off this page. Take a look at number 12. Number 12, first thing I notice is that I have this minus 8 that has to go. The way you get rid of a minus 8 is by adding that 8 across. So negative 8 plus 8 cross out here. And I have 2.1 to the 2x equals 4 plus 8 is 12. At that point, I cannot divide that 2.1. This is the base of the 2 to the x. So I'm going to have to do a log base 2.1 and a log base 2.1. From there, log 2.1 and 2.1 cross out. My 2x is going to come down. And then in the calculator, alpha window, come down to your log base, which is number 5. And then I'm going to make my little number the 2.1. I'm going to make my big number the 12. So I get 2x equals 3.35. Now notice, really it's at 3.349, but that 4 is going to bump up because of the 9 after it. Then from there, divide by 2. So 3.35 divided by 2 gives me 1.67, which is 1.68 when I round it off. Okay. Turn over to the back side. So we got most of the front there done. Turning over to the back. Okay, let's work a couple of these. Let's say we're doing number 14 here. Now, number 14, you could do by logs or you could do it by common base. It really doesn't matter to me. And the reason why is that 8 and 4, those guys have a common base to where I could bring that back to be a base 2. So I'm going to choose to work those that way, but you could do it via logs and just do a log base an 8th. So remember that 8 is the same as 2 to the 3, but I'm going to have to turn it into a 2 to the negative 3. Now hopefully you remember it's a negative exponent because it was a fraction. Okay? So I do 8 is 2 to the negative 3, then I have an x minus 1 left over. Other side is a 4. 4 is 2 squared, but I have to turn it into a 2 to the negative squared, 1 minus x. Then from there, I can cross those common base 2's out, and I can distribute that number from the front into each of those. So my first one, it's a negative 3 times x is a negative 3x. Negative 3 times negative 1 is a plus 3. Other side, negative 2 times 1 is a negative 2. Negative 2 times negative x is a plus 2x. And then from there, I want to bring my babies over to my mama, so I'm going to minus my 2x across. Negative 3 minus 2 more gives me negative 5x plus 3. Then I'm going to minus my little 3 across. Negative 2 minus 3 is going to give me negative 5x equals negative 5. And then if I divide by negative 5, I'm going to get x equals 1. Okay? Alright, next one I'm going to do from here is going to be number 15. Okay, number 15, I have 3 to the x minus 1. And then on this side, remember that a 3 square rooted is really a 3 to the 1/2 x plus 1. And so then from there, I can cross my common 3's out here and here. And then kind of just like last time, I'll have my x minus 1 come down. Half x is going to give me a half x. And then half plus times plus 1 is now a plus a half. Now, what I would do from here is, if you don't like all these little halves going on, remember that you can always multiply the entire equation by whatever you want. So if I don't like these 2's, I'm going to times everything by 2. Here's what happens when you do that. My x is now a 2x. My minus 1 is now a minus 2. But then when I times the 2 on the half x, well, look what happens. Half x of 2, half of 2 is now a 1x, fraction's gone. Then half of 2 here is now a plus 1. And then from there you can just finish solving it regular. So I'm going to minus my little baby over with the mama. 2x minus 1x is x minus 2 left over equals 1. And then to get rid of this minus 2, I'm going to plus that 2 across. So negative 2 plus 2 cross out, x equals 3. Okay? Alright, we're going to go straight down the middle for these last couple, and then you can finish on your own. Now, for the rest of these, I would recommend getting out that yellow sheet that has your common base chart in it. Okay, so I went ahead and grabbed one. I'll put it up at the end of the video so that you can pause it if you need to look at it. Let's say we're doing number 17. So I see that I have a log. Well, then I'm going to do 25 up to the x, bring it back around, equals 125. Then I'm going to pull up my chart here, and I want to see if 125 and 25 share a common base. Okay, well look, you see them both right here. Okay, 25 is a 5-2, 125 is a 5-3. So 25 is a 5-2, x hanging out, 125 is a 5-3. And then remember, once I get them into a common base like that, I can cross out my 5's, 2x equals 3, and then divide by 2. So x is 3/2. Okay, take a look at number 18. 7 up to the negative 2 equals, bring it back around, x. Now remember, a negative exponent, just like we said up here, okay, a negative exponent turns into a fraction. So I'm going to look up 7 squared on my chart. 7 to the 2 here is 49. Well, then 7 to the negative 2 here is 1 over 49. And notice my x is already by itself, so I don't have to keep solving from there. Alright, next row. Notice here my base is an x. Up to the 2 is 81. And then I'm going to look at my charts and see what 81 can be where I'll have a power of 2. So if I look right here, 81's in this chart. 81 is 9 to the 2. So if I rewrite my 81 as a 9 to the 2, then I have an x to the 2 equals a 9 to the 2. And remember that whenever these guys match, I can just bloop, bloop, cross them out. X is 9. Okay. Let's do 21 right next to it. Set up your loop. X up to the 3 equals 343. And then I'm looking for 343 in a cubic power. So I notice here, okay, right in this one, that 343 is 7 to the 3. So if x to the 3 is 7 to the 3, then I can cross these 3's out. X equals 7. Alright, last two rows. Take a look at number 23. Okay, I'm going to start here. 3 up to the negative 3. Bring it back around equals x. Then remember what we said. Anytime you get a negative fraction, you're looking the number up in the chart and then turning it into a fraction. So 3 to the negative 3. Well, 3 to the 3 is 27. Then 3 to the negative 3 is 1 over 27. And that'd be your answer. Okay, next one kind of like that. Let's do number 22. Okay, I have 2 to the negative 2. Bring it back around equals x. Okay, well, I'm going to look up 2 to the 2 in the chart here. 2 to the 2 is 4. But then since this is 2 to the minus 2, it's going to be a fraction. So instead of 2 to the minus 2 being 4, it's going to be 1 over 4. Make sense? Okay, last row. Let's do number, let's just do number 8. Okay, so look what it says. It says 8 to the power of negative 4/3 back around equals x. Now, I'm going to teach you two ways to do this. The first one's going to be harder. The second one's going to be to check your work. Remember that whenever we have a negative, that means that we're going to flip this base. Now, if my base is an 8, that means really it's an 8 over 1. So when I flip that, that's a 1 over 8 to the 4/3. And then the other thing that I can do from there is remember that my 4 is going to turn into a 4th power. My 3 on the bottom is going to turn into a cubic root. And then remember your strategy. You always want to go bigger before you go smaller. So let's say I'm doing the 1 on top first. The cubic root of 1 is still 1. And then if I do 1 to the 4th, I still get 1. Now let's do 8 on the bottom. The cubic root of 8 is 2. But then 2 to the 4th, okay, I can pull out my little chart here. Okay, 2 to the 4th is 16. So that means my answer there is 1 over 16. Let's do one more like that. Let's take a look at number 26. Okay, I see I have a 4 here as my base. So that's 4 up to the negative 5 over 2 equals x. Next thing I notice is whenever I have a negative, I have to flip my base. So if it's a 4, I change that into a 4 over 1 so that I can flip it. Then my power is going to be 5th power. And then my 2 here is a square root. Now remember, you're going to go one at a time. So I'm going to square root the 1 first. Square root of 1 is 1. And then 1 to the 5th is also 1. Okay, now let's do the bottom. What's the square root of 4? Square root of 4 is 2. And then 2 to the 5th is 32. Now, let's say that just confused the crap out of you, okay? All you have to do, if you want it, this is kind of lazy, but it'll work, okay, is if I go back to here when I did my loop, 4 up to the negative 5 over 2, okay, and it'll give you a decimal. Then remember your math, enter, you can turn that back into a fraction. Bam, 1 over 32, same thing. Okay, let's say I wanted to do this one the lazy way. I'd take my 8 here, I'd raise it to the power of negative 3 over 2, or wait, hold on, negative 4 over 3, sorry, I said that wrong. Negative 4 over 3, bam, get it, rando decimal, math, enter, 1 over 16 is my answer. Okay, so you should be able to do it this way, especially if you're taking calc next year, but if you're a senior and you're almost done with math, you can just type it in. Okay, good job.